Hello and welcome back to my Fabric Modding Tutorial Series, Episode 2. This episode we're going to cover project management. You may be asking, why are we covering project management? This is a modding tutorial. You are probably expecting me to go right into the actual modding. However, I'm just going to cover a whole bunch of stuff in this episode that's really good to understand before actually getting into coding and creating what you want to create. And so today we're going to cover several topics. We're going to cover how to use semver to properly version a mod. We're going to go over some Java conventions that you should use in your mod. We're going to go over how to use Git to manage the version control of your mod, and also how Gradle works in importing dependencies into your mod. To begin, we're going to start with semver. Semver is a versioning system so that you can properly version your mod according to a standard. And so this standard gives an easy way to look at for other people to see how much changed in your mod between two releases. It does this by making a very simple format of major.minor.patch. And so to explain this, we're going to go find the version number in our mod. And so that's stored in the file in the Gradle.properties file. If you just find that in the file manager on the side here, and you can see I've already set my mod up in semver. Yours may say 0.1 dots or dash snapshot. And so yours is actually not in, well, yours is in somewhat proper semver as it goes right now. However, I prefer just using the normal standard even while in development, just because it makes it easier if you export random builds here and there to help people debug your mod or help you debug your mod with other people. So we're just going to set our mod version here to 0.1.0. Now what that means is the semver standard is major.minor.patch. So a major version is a version where you make something that's completely different, you completely change a system, something's completely incompatible with the previous version. The minor version is when you add new functionality or a new feature in a backwards compatible manner, aka when you just say you add a new block or a new item to your mod. This would be a case for bumping the minor version number. And the patch number is for when you make a bug fix or just other very, very small change to your mod. And you're supposed to bump the semver number no matter how small the change was. So even if you added a line to your mod, that's still worthy of bumping the semver version, even though you didn't really do that much. But it just shows that it's different from the last version, no matter how much it is. And now, why does this matter? Why do we bother using semver in our mods? And part of this is because it's the officially supported standard by the Fabric loader, and it means that other people can check for versions of your mod if you're making an API or even if you're just making a normal mod. It means that the Fabric loader can easily tell people to download a newer version of your mod or an older version of your mod. And also it's just very readable for people since it's the standard. Next, we're going to cover some other Java conventions that you will want to use in your mod while developing it. And so the first one we're going to cover is Camel Case. And this is just a standard that I'm sure you know if you've programmed in Java at all. But I'm just going to show you within the tutorial mod package. And this just is the standard of using a lowercase letter to start the first word, and then an uppercase letter for each word after it. Pretty simple. Next up is class names. The capital should be, all words should be capitalized in a class name. So, tutorial mod, both words are capitalized. Mod initializer, both are capitalized. Next is constants, anything that you don't expect to change during runtime. And so this generally applies to any fields that are static final fields that you just set kind of like this, like fields that probably won't change later. And so here, or that you're sure won't change later. And so the standard for this is just to put the constant in all capital letters like I've done here. Mod ID is all capital letters. And that just makes it clear that that's something you can always rely on to be the same. Next is curly bracket placement. There's two different standards for this. I prefer the one that is already being used here, with one bracket right here, one bracket down here, and there's another standard which is this, one bracket down below the line where you're declaring your method, then the bracket, other bracket in pretty much the same place. But I'm going to be using this style. You can use your preference, however, I recommend this style. Next up is indentation and new lines, and for the most part your IDE should handle indentation, and there are a few plugins that can help you with this to make it easier to see when something is incorrectly indented. However, I use one for my benefit, and it makes my code a whole lot more readable. Something else that is very important in code formatting is new lines. And so usually a new line will be used if you have a line that is longer than can fit on your monitor that just has multiple parameters that are exhaustive. So say I have system.out.println string.format. This is a small example and really not worth actually using this, but say that the parameters were maybe 2 or 3 different lines worth of code, like just hard to scroll through, then you could just put them on new lines like this and do line 1, comma, 2, comma, 3. And then there you have, it's properly spaced so that it's a lot easier to read now. The only thing that's left is Javadocs, and checking that your Javadocs are correct, or Javadocs are a way of correctly documenting our code so that others can read it. So the first Javadoc, or a Javadoc for the oninitialize method would just be, and my IDE will apply it here, would just be initializes the mod. And that's all you have to put in it. There's a few different tags you can use to better let people see what the Javadoc, or what the method does. But that's all you really need, is to just have this little comment structure here, and that just shows off that that's what this method does and how it does it. And I have put a link in the description of a whole bunch of Java conventions that are very widely accepted and are from the Oracle page, so they should be up to date. Third on our list to cover is Git. Git is a version control system. that allows us to see when changes were made in our files, and helping us coordinate said work among multiple people or even just ourselves. It can help for organization. And so how Git works. Git is a system that stores projects in what's called a repository. And so a repository just means a folder where Git is applied to. Commits are then made to that project, and that's essentially marking your code as a point in time. It's saying this is how the code looked when this happened, or when this point in time happened. And so we're going to create a Git repository inside of our mod here to help us better manage our mod and ensure that we can see when changes happened, when we broke things. And so to do that in IntelliJ, you can just go up to the VCS tab up here, press Import into Version Control, and go over to the Create Git Repository button over here. And it should just automatically set the path correctly. Just press OK. And now you'll see a whole bunch of the files on the left here turn red. This means that Git currently has no idea what those files are, what they're doing, and so we have to commit them before Git starts tracking them. And by default, your git ignore, if you followed the first tutorial, should be populated with all of this stuff. If not, you simply want to right-click on any file you want to hide from Git, which are pretty much these top 6 folders except for the Gradle folder. So run, out, build, idea, and .Gradle. You want to make sure that those are in your .git ignore, and you can add them by just right-clicking here, going down to the Git down here, or going down to Git down here, no, that's actually the wrong thing. And so you can add something to your git ignore by simply taking the You can add something to your git ignore by simply taking the file name and just putting it in. So IntelliJ will automatically show you some tips for what you're trying to add. So you just want to type in .gradle, and you'll see it automatically makes .gradle, and it turns it yellow because I've already done it in here, up here. But that's how you define a file in your git ignore. And that just makes Git not keep track of those files because it doesn't need to. So next we're going to make a commit and tell Git that we have a point in time, or the first point in time, to store our files at. So first we just see all these and make sure that there's none in there we don't want, and it should be about 13 files. Just hit the checkmark box here and type into the text box here initial commit, and then go down and click the commit button. And it will perform its code analysis and check that all of our files are good. It will automatically tell us that a few of them contain problems just because Fabric has some things that it doesn't particularly like. That's normal. Just go ahead and press commit. And then you can delete the commit message from this text box. And what we've just done is created a commit. And that's a point in time where it says, here's what your code was. And if we make another commit, then it shows us then we can still go back to this commit and say, this is where we made that change, or this commit in specific, this is where we started. And so we have the initial commit. You can see down here in the Git tab to log, you can see that it has all of these files in the initial commit. Now, we're going to create another commit that has a few changes. As you can see, I've already changed this a little bit and added a few things, and I don't particularly want those. So I'm just going to delete all those. You can see the file turns blue, which just marks that there are changes to the file since I last made a commit. So now what I'm going to do is I'm going to go over here, select all the changes that I want to commit, and say removed unneeded print statements. And now I'm just going to commit that. And now, if we go down to our Git client, it's called, down here at the bottom, we can see when we click on the second commit that I only changed this file. And now I can double click on it to see exactly what changed in that commit. And we can see that on this side is the old file, on this side is what it is now, or what it is at that commit. And so you can see we've removed the print statements that were there. So that's just Git is just a handy way that you can ensure that you never make a change that isn't tracked and that you can't go and find again, as long as you're making commits regularly. And there is a link in the description that explains how Git works a lot better, because Git is a very complicated topic, however very simple if you don't want to go very deep with it, which you shouldn't need to for the scopes of this project. And so we're just going to press minus on that. And you may have heard of GitHub, which is a service that uses Git, and it does not have Git itself. Git itself is completely on your computer. GitHub is just a place that stores your code that you have sent to its servers through Git. And so, of course, the link in the description explains that all a lot better. This is a very hard topic to explain in full. However, you use the resources and take your time, you'll figure it out. And now, the last tool on our list is Gradle. Gradle is a system that we use to manage the dependencies in our mod, and also just to run some stuff that we don't necessarily want to do ourselves. And so, one of the things that Gradle does for us is of course, if you go into the external libraries tab here, you can see it imports all of this for us. And those are just a bunch of libraries that come with Fabric, and those are normal to have in your development environment. And this is a whole bunch of the Fabric API, and it just imports all of those so that we don't have to manually go and add them ourselves, which is a lot harder. And it does that by reading this build.gradle file and adding what we ask it to add. So you can see we're in this dependencies block, we have Minecraft, and it's using the Minecraft version that is specified in the Gradle.properties file. And so this is the Minecraft version that we're using that it's referring to with this little bit right here. And same with the rest of the curly brackets here. It's just referring to values in here. And so mappings, which I'll explain in a later episode, are another thing that are important to have in our build.gradle. The Fabric loader, of course, because without it, our mod would not load. And then Fabric API. It's actually optional. It's not completely required. However, I really recommend you leave it in. If you want to take it out for any reason, you can simply just delete this line, like so, and it will no longer be in your project. However, leave it in, as it's a very useful tool to have. And so this system allows us to have dependencies and keep things in our mod so that we don't need to manage them ourselves. And so sometimes you may see some other keywords than just Minecraft, mappings, and mod implementation. Some of those are mod runtime instead of mod implementation, and what that does is it simply imports the dependency, but only when we're running in the development environment. And so you may want to use that for something that makes your game a little bit faster to make it easier to develop, like sodium or lithium or phosphor mods. And so it's just an easier way to make sure that we don't accidentally get that included into our mod when we try to release it. And there's another keyword called include that actually does the opposite. If I was to use the include keyword and then copy paste the string from here over in front of this include keyword, it would actually, when we build our mod as a jar to make it ready to put in somebody's mod folder, they wouldn't have to go and download Fabric API on its own because it would be inside our mod. And that's the basics of it. There's a lot more to it, and I of course have put another link in the description that will make a whole bunch of this a little more clear, but that's all you really need to know, and I'll be walking you through whatever Gradle stuff we need to do through this tutorial. So now that we've gone over all of the different tools that we use inside of our development environment to make development easier or just make it a little bit nicer on ourselves, now we're ready to start developing a mod. And the next episode may still not be actually developing a mod. However, I'm going to try and teach in this series, as I said in the first episode, how to learn how to learn. So I'm going to try and teach you how to find the tools yourself so that you aren't lost when I eventually finish this tutorial, as I often was following tutorials myself. And so I hope that you enjoyed this episode. I hope it was informational. I don't think that's a word, but I hope it was informative. That's the word. And I really recommend looking into some of these things more if you have an interest in any of them, or if you don't think I've explained it well enough, because there are a lot of places that will explain it far better than I can. And I've put some links so you can get started down in the description. However, just Google any of these things and you should find some worthwhile information on them. Anyways, thanks for watching, and I hope to see you next episode for a code digging tutorial.